This is Kertas Model 4, Paper 1, question number 18. So before we start to solve the question, we have to know that this is from which topic. It's a Form 4, Chapter 9, differentiation. Yeah? How do I know? Because we have the rate of change. The rate. That is the keyword. So the diagram 18 shows a water tank. The volume of the water tank is given by this. So we have V equals to 4 pi H cube. Okay, it's given. Next, where H is the level of the water in the water tank. When the tap is open, the water flows out from the water tank at the rate. So we have to write down, this is the information we get. Yeah, the rate will always D, let's check the unit. It's m cube. That means dV by dt. This is the rate of change, 0.2 pi meter cube per second. So the unit will tell you actually what is the quantity that it's involved. Next, we need to find the level of water in the water tank. At the instant, the level of water decrease at the rate. Oh, we are given the level of water decrease at this rate. So we are given dH by dt equals to 0.05 meter per second. This one is slightly different from the usual question that we solve, but never mind. These two are the things that we have, and we need to find the H. The normal question is you're given this, and you're given this, and you need to find this. But now we have this too, so we have to find in another way. So how should we start? Well, we should start by using the information given. You see dH by dt, which one you want to split? You want to split this also can, you want to split this also can. So let's try to split probably the dH. Always split the second one. Okay? So dH by dt, let's split it. So dH, we split it into two, then we chain them together with the V that we have. Okay? And next, we have dV by dt, isn't it? So we shall put there 0.2 pi. No need to put a unit, yeah? Next, do we have dH by dV? Now, V is a bigger quantity, whereby H is the smaller quantity. Therefore, we need to find the differentiation that involves the V and the H. So on the other hand, we are given this V equals to 4 pi H cube, isn't it? So we can find differentiation of V towards the variable H. Then over here we will have 12 pi H squared. So let's put this one in here, but we are not looking for dV by dH, we are looking for dH by dV. That means if this is 12 pi H squared over 1, this side will be 1 over 12 pi H squared. And at the same time, what else do we have? We have dH by dt, isn't it? So dH by dt is 0.05. So isn't it now we form an equation? Let's rearrange so that we can find our H squared. The things that we want to find go up and the 0.05 come down. So we will have H squared equals to 0.2 pi over 12 pi and the 0.05 put down here. Pi and a pi can be cancelled off. Now let's calculate this one. We have 0.2 divided by 12 times 0.05. The 12 times 0.05 is actually the denominator, so both divide the 0.2 together, yeah? So we will have, 0.333. Can we just change to fraction? Yeah, 1 over 3. Okay, so this is 1 over 3. And therefore, if we want to find H, we need to square root of 1 over 3. Okay, no need to put the negative because height can never be negative. So that is our answer. We can just leave this as our answer, or you don't want, you prefer the decimal number. Then we square root the 1 over 3. We will have 0.5774 meter as our answer. Okay, so either one get you 1 mark. All right. And then this give you 1 mark. And then identify your, yeah, you differentiate this 1 mark. Or if you can identify dv by dt, sorry, if you can identify dv by dt, you get another 1 mark over here. Okay, that's it for question number 18.